after entering that nuclear force. So we should bother about now what like inside the nucleus will go further. Inside the nucleus means something will enter into the binding energy principle. The last one, radius, no? Okay, one more thing, radius of nucleus. So the radius of the nucleus is given by R naught into A12, and we know what is A. A is a mass number or number of nucleons, and R naught value is given by 1.1 1.1 into 10 to the power of minus 15 meter. Like this, the radius of nucleus. Then we'll go for the density of nucleus. The density of nucleus. Density of nucleus. So how you define density? Mass by volume. What is the mass? Like a total number of nucleons. It should be equal to A into mass of each nucleon. No? The density we define like this, M into A. Then again, volume, what we can write? 4 by 3 pi R cube. So when you substitute this, A, Mn, 4 by 3 pi. What is R cube? R naught, A to the power of 1 by 3. So I think this everything will become Mn, 3 Mn, 4 pi R naught, 1 to the power of 3. All these are constant, no? So therefore, almost all nuclei will have same density. Is it okay, no? So shall we put like density of nucleus? So shall I say it's independent of mass per unit, the density within, shall I say independent of mass number? What is the total mass? Mass of each nucleon into total number of nucleons. That is mass number. So shall we put like density independent of
R naught cube, sir. Sorry, R naught power 1, sir. R naught cube.
R naught cube, okay, that one. Independent of, shall we put mass number? So almost all nuclei will have same density, is what is telling here. Okay, got this? So these are about the basic. The last one is what? The binding energy. Why this binding energy idea will come? So let's go back to the hydrogen atom. There's a electron. What is the energy of hydrogen atom? Minus 13.6 electron volt. If it absorbs a photon, of 13.6 electron volt, let's assume that, and it is a test, then what will happen to this electron? It will get separated. So shall I say that this particular electron is binded to hydrogen atom by this much of energy, and if you supply energy equal to binding energy, what will happen to that electron? Will become free from the nucleus. This is the core central part of our discussion. If you supply energy equal to binding energy, if you supply energy equal to binding energy, then what happens? That electron will become free from the influence of the nucleus. It will get separated. To infinity. Shall I say that, shall we put like this? If you supply energy equal to binding energy, what will happen? Then that particular system will break up into its constituents. What are the constituents of this hydrogen atom? There's an atom, no, altogether. So when you supply energy equal to binding energy to a system, then the system will break up into its constituents, or break up into its parts. What are the parts? Electron and the nucleus are the parts. So it will break up into that one. So in a very best way, I think in SURMA, I think he has really beautifully, he has given diagrams. The same thing I'll recollect here. So this day, I think that one, so it contains neutrons, protons, in a very simplified way. I think there's the one best diagram is what I've seen. Even in foreign author books also it's not available much. He has really give some. If you supply energy equal to binding energy, it will break up into its constituents. And you can show a little bit far away. They'll get separated, that one. Similarly, what will happen? Similarly, if this particular thing, if it combines here, and if it combines all these constituents, if it combines, then we'll get a binding energy. Binding energy, this will be what happen available. And this you find a little bit difficult. So what are these? These are the constituents. And this is system. Let's say that. You open the system. Breaks up into its constituents. And this is what? Energy supplied to system. This is the idea, that one. Then the system will break up into its constituents. Similarly, these are the constituents. If the constituents combine to form a system. So what is this? What happened here? Constituents combined to form a system. Then what happened? Binding energy will be available. Or released, it's left to you. Released, I'll write it. And this will be better for numericals. This word will help you here. So let me just take the same example of atomic structure. This will be much easier for you. Let me proceed with this example only. I'm bringing everything in one separate page. Now, if you supply energy equal to binding energy of the hydrogen atom, it will break up into electron and nucleus. Similarly, if electron, and this is a proton, they are far away, separated by infinity. If this proton captures that electron and forms hydrogen atom, anything will happen. I think we have discussed some numerical also, this one. So somehow what happens, this proton is able to capture that electron. Let's assume that. Then here, this hydrogen atom system is formed in the ground state. What do we get here? Plus, there should be a photon, no? Photon of how much of energy? 13.6 electron volts should be released here. Say released. Yeah.
13.6 Z square, sir.
What you're saying? Correct, no? This will be
13.6 Z square.
Z square is Z equal to 1, no? Proton, hydrogen atom.
Represented it as Z, no, sir. That's why I thought atomic number you took as Z.
No, it's a proton, no. Just proton means Z equal to 1 only. Hydrogen atom.
Okay.
Okay, is that okay? I think this is the best way. Like if this is a hydrogen atom form. Suppose if proton is able to capture the electron, which is separated far away, there's no initial interaction potential between them. Then if it forms hydrogen atom, the system, then what happened that earlier, what was the energy? 0 electron volt, now minus 13.6. So then 13.6 electron volt, that particular energy should be given out, no? a photon will be liberated here in this system. Similarly, if you supply energy of 13.6 electron, what that 13.6 electron shall I say binding energy? If you supply energy equal to binding energy to a system, it will constituents. They're the core idea of the binding energy. Okay, next question comes like, let's get into nucleus. Like there's a background with what we have developed here, binding energy. So what makes the proton neutrons? Let's come into this one. Look at this. Proton, what happened? Proton, 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 proton. We do have like this, no? So this proton, proton, they will repel, no? Then what makes them to be binded? Okay, neutron, okay, sir, neutral, nothing will happen. Leave it. Proton, proton, repulsive force, here repulsive force, here repulsive force. Then what makes them to be binded together? Yes, there is some binding energy available in the nucleus. From where that energy will come, I'm going to take like this here. So when I go and get into the nucleus, so why this binding energy will come? Because you see that one proton, proton, repulsive force is there. Proton proton is repulsive force, then definitely what happen, this protons should under electrostatic repulsive force should act, and the proton separation between them increase, and the radius of the nucleus must increase, but such a thing is not happening. Then who is balancing that repulsive force? Somebody. Attractive force, nuclear force. The nuclear force acts means there should be energy, because we have developed this, getting the idea, we have developed this situation, there must be energy. So from where this energy has come, yes, that's called what we call binding energy. From where that binding energy has come. So when I actually take the best example, let me take helium nucleus. Helium nucleus. So how to make the helium nucleus? Two neutrons, two protons. They'll combine. I'll measure the mass of system. Let me call that as initial mass. So what it is? 2 times of mass of neutron, 2 times of mass of proton. And so it will form an nucleus. So this is neutron, proton, proton, neutron. Anything you can write it. This will be. So this is what happened. Mass of the nucleus. So let me call final. I'll measure this mass. There's nothing much. Shall I say alpha particle or helium nucleus? Better you call. When I measure this, what I see that slightly different. I think some data I needed. Mass of helium nucleus. No, so we have mass of neutron. This is 2 into 1.008665 U plus 2 times mass of proton 1.007825 U. I'll calculate that initial mass. Then mass of helium nucleus, I know it is how much it is, 4.00260 U. Check it. This Mi will be greater than Mf. I'll call that as mass defect. The way to that delta M gone mass means, suppose say there's a 1 kg, 1 kg, 1 kg, 1 kg, 4 kg, no, let's assume. So when I combine them, then I'll make a ball, new nucleus. It should be 4 kg, but when I go and measure, it's 3.9 kg. Where do there 0.1 kg gone? Where do that 3.1 kg gone? So here, so that will become a binding energy, which is equal to delta M into C square. So when I measure this mass defect, no, so I'm getting, let me write directly value 0.030. If you want to calculate afterwards, into C square. What is U? U is 1 atomic mass unit. Substitute that. So how much we are getting? Okay, there's only delta M. Now the binding energy is given by delta M into C square. So this will be 0.03038 U into C square. So 1 EMU, 931 will take it. 931 approximator by C square it is. This into C square. Mega electron volt. Okay, this much is the binding energy of the helium nucleus. How much it is coming? 28.3 megaelectron. This where do this energy available? Binding energy which is available to bind the nucleons together is used. This much of energy, this energy is used to bind the nucleons together. So this how they are binded. They are binded by this particular energy. That one. So there's a one mathematical way of calculation. This binding energy again depends on what all parameters we'll see later. Like that in every nucleus. So when you measure the mass of its constituents and when you measure the mass of nucleus, the difference of that mass is what? Mass defect. And the delta M into C square will become the binding energy. And this binding energy is utilized to bind the nucleus together. And from where that what happened, the binding energy will come. Now to break up this helium nucleus, how much of energy I should supply? 28.3 megaelectron. If you supply 28.3 megaelectron to the nucleus, so what will happen here? It will get converted into constituents. So what we are using some sort of Einstein's energy mass equivalence, no? That formula only. The difference in mass will get converted into what? The binding energy. Means, sir, E equal to mc square, is it what? Applicable for what? Only for subatomic particles. That's what the present physics is saying. So can I apply for 1 kg of tomato? This particular energy mass equivalence of Einstein equation equal to mc square is applicable only for subatomic particles. That too inside the nucleus, what we are seeing. But if you look at the Upanishads, no, they are going beyond this quantum mechanics, even this energy mass equivalence. I think nowadays some of you might be doing, no, Pitru Paksha it is called as, no, forefathers are being worshipped for this particular thing, that one. Till I think September 19, it started on September 4th, I think. For 14 days we'll worship our forefathers. Every day I think they'll do Tarpana, Pindadana, and on September 19th we have Mahalaya Amavasya. What is the principle behind? And if you look at the Upanishad, in one of the Upanishad, what Pen is discussing this, I too got shocked. That one. It's a higher level Sanskrit where you have to put lot of effort. What is telling like? What is that Pindadan? They say like, when you recite that mantras, the mantras are so powerful that the rice ball. So what will happen is a part of the mass of that what happen will decrease, and that mass what will happen will get converted into electromagnetic wave, and that energy what happen will flow to the world in which your ancestors are staying, and that energy will help them to come out of the troubles what they're facing in that world. That's what the Upanishad is saying. The rice balls, that particular thing, when you recite that mantra and when you leave that tarpana water, no, and that particular mantras will make that particular mass to get converted to energy, and that energy what happen will become EM wave, and EM wave can propagate no problem. See, rice ball cannot move, but EM wave can propagate, and that's what they're telling. Science, I don't know, I don't think so. We have any experimental data on that, but the Upanishad says so. We are head to prove that one. So I was really shocked. I was used to question like, why my, I used to question my father, mother, like why my ancestors, in which world they are, we don't know. How this ball will go there, rice ball. How the tarpana what I live will go there. I think who can answer that? Nobody know. Then since I'm science background, so when I came across Upanishads, no, so we do have that description. Again, don't say that Einstein read Upanishad and brought this. Nothing to do that one. In very codified language in that Upanishad, it is there. So there's a means maybe some methodology is there. Maybe the Vedic mantras are so powerful where they're able to convert matter into energy. God knows. But as such, physics, what we know, we can't means like a house, because when you recite mantra, what you're doing, sound energy, no. As such, the physics, what we know, with the help of the mechanical sound wave, you cannot convert matter into energy. That much is what I'm very sure. Research is going on. It's not that research is going on, but as such, we don't have that. Till now, there is no breakthrough where the mechanical sound wave can convert matter into energy. But matter get converted into energy is what we have example. See, it's like a shall I say that what we know science is very little. See, that's what, like when Einstein, Bohr, what happened when they discovered, when they saw that electron is a wave, no, not a particle, no. Then what happened? They came across Upanishad. When they started reading, no, they got shocked. After, and almost what happened in 19, I think 31 something, they all gathered together. They took photograph. Earlier last class I told, no, that photograph is only to conclude what to do with physics. Then what happened? Then few of the scientists, they were not knowing. They told like, no, in Upanishads all this information is being described. They were shocked. How come such a thing nowhere in the Bible or Quran or no scriptures, only in Upanishads it's available. Not in all Vedas. Only in some part of Veda they're called as Upanishads. There are higher scientific things available. Then okay, something and all. Then most of them they started reading. Then the Western people, they started giving respect to India because of Upanishad, not because of any other thing. Why do we have still some higher respect for Indian science and technology? Means because of Upanishad. Because the Upanishad talks about all quantum level only. And still science is yet to prove that one. What all, so like you look at any scientist autobiography, that they give due respect for Indian scriptures, because they say like something very beyond the reach of human intellectual things are available in that. That's what I know. So even it's very difficult to understand. I'm telling this one. It's not that easy. You just take one Upanishad, read it. No, you, sir, I am not seeing anything. What you are saying, you say, because the language itself is so lucid. Lucid, we say, means it's the coded form. One word, what if you start interpreting, no, it may give 1,000 meanings. To that extent, things are there. And just 3 lines, if you start expanding, no, you have to end up 50 pages of explanation. To that extent, they have compressed it. To in that codified language is what the Upanishads are available. So it's a very high sense. So I feel like there's a lot to explore. Still science is not over. There's a lot to explore. Nothing is over that one. And if you feel that, okay, I'm very good student, I know everything, means then you are like in a frog in a well. You are frog in a well, that one. So still a lot of things have to be explored here. So I think this will help you to really focus. Means what you know is very little, still a lot to conquer. So how much of the whole life will not be sufficient to really explore that one. So much of things available. Please do read things, not only just textbook. No, daily half an hour you keep